Now, looking at the second of the 4 standard algorithms, we're looking at linear search. What this does is this takes any unsorted array and it looks for a particular value. Now this could be any type. It could be string, integer, single, real, boolean, any array of those types, and it will look for a specified target value. And if it finds a match, then the linear search algorithm reports that a match has been found, and in some cases it will also report the position of the match in the list. So here's the pseudocode for linear search. You start off by setting a target value, because without a target value you can't possibly find any items in the unsorted array. You also use a fixed loop because you should know how many values there are in your unsorted array. So say for example we've got an array of 10 names, we can loop 10 times and guarantee that we will have checked each item in the list. So steps 3 and 6 are our if structure, our selection structure, and what we do there is we compare the current item in the array with the target value, and if there's a match we report that a match has been found at step 4. Sometimes step 5 is quite useful to return the position of the match in the list. For example, if you had 2 arrays, one which has usernames, one which has passwords, and you ask the user to type in their username, you would then use a linear search on the username array, find a match, say at position 4. You could then store the position of the match in the list, and then prompt the user to enter their password, and use that position, which would be in position 4, to compare what they've typed in to the 4th element of the password array. So there's an example of where positions might be quite useful. But remember, it's a fixed loop, so it doesn't stop as soon as it finds the first match. It will continue on to the end. So if there are a number of similar items in your unsorted array, it would only return, well, it would report that a match has been found more than once, but it may also, if you're using a single integer variable rather than an array, it would only store the last position that it had found, and this may cause some problems. So if it's displaying it later on in the program, so you have to keep that in mind. The fixed loop will always go to the very end of the linear search, and if it's storing values in variables, it will probably only store the last value. With sorted versus unsorted arrays, as I was saying on the last slide, linear search does work best with unsorted arrays, where you know the length of them. So it's the most efficient way of finding an item in an unsorted list. At higher, you only really need to be able to use unsorted arrays, but you do need to know the theory behind sorted arrays. That's something that comes in at advanced higher. So an advantage of an unsorted array is that it's very easy to add additional items. If you have a 10 item or 10 element array and you have space to add some more items, you can just simply add a new value to item position 11, for example. It doesn't matter what order it's in. Downside is it's very slow to search because the linear search has to go through every single item in the list. Now you can improve that by using a sorted array. So here's an example. If we took an array of values and we sorted them in ascending order, so the lowest number is at position 0 and the highest is at position 9, for example, we can use an alternative way of searching through the list. I'll tell you what it's called. It's called a binary search, but it is advanced higher level, so you don't have to know how it works. Okay, all you have to know is that with a sorted array we can search through that much quicker than we can an unsorted array. There are downsides though. You have to sort it in the first place, and that takes processing power. It's very difficult to maintain, update, or actually add new data items, because you would have to move elements in the sorted array down to give you a space to put in the new addition. And the reverse of this is also true. If you delete an item from the array, you would then have to move the following on elements up one level in order to leave it sorted and tightly packed together.